Okay. All right. Let's see. Good evening. Can you guys hear me? Yes. Okay, perfect. Okay. Let's start. Everybody got my email? Yeah. Tonight about things to do and things not to do. Oh my God, you're already ready. Rainy. Okay. 1A. Final review. Q9. Okay. Q9. Give me a second. Hold on. Q9. Yes. Okay. Is it the one with the linearization, right? Okay. Fi. Well, it has W, right? Is that what you mean? All right. So, yeah. Okay. Perfect. So we have a function. Um, you should also do the one that's similar to it on the handwritten one. You should do both. So, so you have a function W. You have no idea what it is. But you know that W of 3 is equal to 7. So y is equal to 7 when x is equal to 3. And then you also know that the limit h goes to 0 of w3 plus h, that's h, minus w of 3 over h is something. Okay, so the question is, find this, right? What is that equal to? Well, the definition of this is for any x. The derivative is equal to the limit as h goes to 0 of w of a plus h minus w of a over h. So if this is 3, that should be 3. And they give it to you. Here it is. This thing is the derivative. And it's negative 4. Okay, that's the definition of the derivative. So this is equal to negative 4. That's given. Okay. And then they say to you, here's another function. Right. So suppose you don't know the rest, right? The previous stuff, you don't know anything about it. And I say, oh, here's a new problem. And I start with this. And I say to you, can you give me a formula for the derivative? Okay, def. So what rule are you going to use to find the derivative for g? Since g is given to you this way. The product rule, right? So you say the derivative of x times w plus x, the derivative of w. Okay, the derivative of x is 1. Okay, so w plus x, derivative of w. So that's the formula for the derivative. So if you want the derivative at 3, you're just going to plug in 3 for x inside here. Okay, so the derivative is w of 3 plus 3 w prime at 3. W of 3 is given to you, is this number, 7. W prime at 3 is this number, negative 4. And then you have a plus 3. So that's the answer, whatever that is. Again, don't simplify. Okay, suppose, let's stick with this for a second, and then we'll go to the other parts. So suppose you were also asked, here's a function, That's equal to, let me think. W of square root of x. Okay. Now, if I ask you for the derivative of this, and by the way, this can be written as W of x to the half. Okay. If I ask you for the derivative of h, what rule are you going to use? The chain rule. Right. So the derivative is the derivative of the outside, leave the stuff inside as they are, times the derivative of the inside. So whatever this is, I don't know what it is because nobody has given me an x, so I can't do anything with it. The derivative of this I can find. It's 1/2 x to 1 less half or 1 less power, right? So I can finish this. So then the derivative of x of h is equal to derivative of w at square root of x times 1/2 x to the negative a half. So x to the negative a half. So if somebody says to you that now find the derivative of h at 9, you can do it. You can plug in place of x 9 inside here, inside here. Okay, so that would be 1/2 square root of 9. Oh, that's good news. That's 3, and I know the derivative of w at 3. 1/9 to the half, which happens to be 1/3. So plug in and you're done. So they can give you all kinds of new functions where you either have to use the chain rule or the product rule to find that derivative, and that derivative will be related to the derivative that just gave you of w at 3, right? So now that you know this point for w, o, and g, and you know its derivative is equal to -4, and you also know the derivative at, let's do this. And you also know that g of x is equal to x times w of x. Therefore, g prime is equal to w, I'm just using the product rule that we just did, plus x w prime. Since you know this, you can find the equation of the tangent line, that's called the linearization, of both w and g. Now you're told to do something with g. So I need to write the equation of the tangent line, that's the linear approximation, the equation of the tangent line to g. So the equation of the tangent line looks like this. This has to be a given point, and this is the slope. This is the derivative at the given point. This x and that y stay. And if you're going to write the linearization, we call this L, to just say this is the y coordinate, not on the function, not the y coordinate on the function, but it's the y coordinate on the tangent line, because you're going to walk on the tangent line. So you want to differentiate between y on the graph of the function and the y coordinate on the line. Anyway, so you're given a point. You're given x equals 3. So if x equals 3, you can find the y coordinate on the graph of g by plugging in, right? So that would be 3 times w of 3. W3 is given, so that's 3 times 7, so that's 21. So you have the point 3, 21 on the graph of g. Okay, but in order to write the equation of the tangent line, you need the slope. You need the derivative at, the graph of g at 3. So you want to find g prime at 3, which we're just asked to do. right? So let's do it again. That would be W at 3 plus 3 W prime at 3. W at 3 is 7 still. W prime is -4. So this is 3 minus, 7. Again, don't simplify. 7 minus 12. So that's going to be something or other, right? So this is the slope. That's your slope. And this is your point. So the equation of the tangent line that I need, if somebody asks me to approximate the y-coordinate on the graph of G, I need to write the equation of the tangent line first. Of tangent to graph of G at the point 3, 21, that's your x and that's your y. It's going to be y minus 21 is equal to slope minus 5, x minus the x-coordinate goes here. Okay, so now I'm going to rewrite this, leaving the y-coordinate alone and calling it L, capital L. You don't have to. I do. I'm going to call this L of x, meaning this is the y-coordinate on the line, on the tangent line. So I'm going to throw everything else on the other side. So this is the equation of the tangent line to the graph of G. So if you have graph of G and somebody went at x equal, this is the G, y equal G of x, and somebody went at 3 and found the tangent line, supposed to have negative slope. Let's pretend that we don't know that because my line doesn't, but whatever. So there's the tangent line. So if somebody goes close by on the graph, either on the right or on the left, just slightly more than 3, slightly less than 3, you can estimate the y-coordinate here by jumping on the tangent because you're pretty close. The y-coordinates won't be too different. That's what they're asking you to do. They're saying, can you approximate G of 3.05? So G of 3.05 will be approximately the same thing that you get when you plug in 3.05 onto the tangent line of G. So this is, again, the tangent line of G at that point. So this is this line, right? So this is approximately what I get when I plug in 305 inside this tangent line. So the x is going to become 305, right? So this is the same as 21 minus 5, 3.05 minus 3. That's the answer to part B. Again, if the question was given just the way it is here, it doesn't say simplify, please, and give me one answer and do all the additions and the multiplications and blah, blah, blah. It doesn't say that. So I wouldn't do such a thing. I wouldn't multiply. That's the correct answer. So the slope, right? So you're told that G is this, right? So I'm going to use the chain rule, not chain rule, what did I say? Product rule. Because I have a product. Here's one thing times another thing. So the derivative of G is the derivative of x, right? The derivative of x here is 1. That's why you don't see it. Times w plus x as is times the derivative of w. So now if somebody wants the derivative, the slope, right? That's the slope. The derivative of G at 3, the slope of the tangent line at 3, I'm just going to plug in into the slope equation x equal 3. So I'm plugging in x equal 3, x equal 3, x equal 3. I'm given w of 3. It's part of the problem. I'm given w prime of 3, kind of indirectly. That was this thing. That's the definition of the derivative. So this is the w, yeah, there it is, w prime of 3. So I'm given all that. So I can plug in here to find the slope. So that's -5. Okay. There's a similar question. What mystery? I don't remember. I'm gonna look at it. There's a similar problem you should do also in the handwritten notes, similar to this. Do both understand how to do those. This is pretty straightforward if you understand what's happening. There's no, okay, let's slow down. So then they say to you, so you have the equation, by the way, you have this equation of the tangent line. So the equation of tangent to G, to the graph of G at the point 3,21. By the way, the slope on G at that point is, what did we say the slope was? -5. So the equation is, we said, y minus the y coordinate equal slope x minus the x coordinate. So now the next question, so just give me a second. Don't ask like all these different questions at once. Let me finish this and then ask. So, so now if somebody asks like they did, write the equation to G of the tangent line to G inverse. You're like, what was G inverse, right? So this is the equation to G. So if you have a graph, no, not like that. So you have a graph and you find the equation of the tangent line. And this blue graph happens to have an inverse. Well, let's say the inverse is this graph. The equation at the corresponding point, if this point is the 3,21 point, the corresponding point will be the 21,3 point. The x and the y will flip in the inverse. So this is the inverse. This is, let's say, G inverse, right? And this is G, graph of G. So if you know the point on the, at a particular point on the graph of the function, and you know the tangent line there, you can write immediately the tangent line at the corresponding point. That's in quotes, I made that up. So corresponding point on the graph of the inverse function. So since I know I have this point on the graph of G, and graph of G has this slope at that point, I can immediately find the corresponding point on the graph of G inverse. So G inverse, I can tell you the graph of the tangent line. I can write the graph of, write the equation of the tangent line for G inverse at the corresponding point, and I know the slope. What would the slope be? If the slope of the blue function is -5, what would the slope of the inverse be? Yes, it's just the reciprocal. Okay, it's just the reciprocal. So that's what they did here. In the last part, they say to you, okay, can you tell me, and they ask it in such a weird way, find the equation of tangent to G inverse that nobody has talked about yet at x equal, they didn't say x equal 3. They say at x equal G of 3, and you're like, what? What is that? That's the 21. Because we just found it. When x is equal to 3, the y in the G is 21. At x equal to 21. So see, they found the corresponding point. So at 21,3. So what you do for the inverse, if you have the equation of the regular tangent line to the regular function, for the inverse, you flip the x and the y's. You flip them, right? And you take the reciprocal, don't change the sign, the reciprocal of the slope. So the tangent line for G prime would look like y minus 3 equal -1/5 x minus 21. Don't forget the parentheses. Okay? No, don't change sign. So, and you can tell. So if you don't remember, do I change sign or do I not change sign? Think of the exponential function that clearly at every point has a positive slope. You can see it, the lines go up. And then look at its inverse. Its inverse is the log function, which also at every point has a positive slope. They're inverses of each other, and they both have positive slope everywhere. So the slope doesn't change sign for the inverse. It stays the same sign. It's just, you just take the reciprocal. Okay. Okay. What was the other questions? So there was okay, so I'm gonna take them one at a time. 6A, can we so 6A in the typed review. Handwritten review. So 6A, so just give me a second. I'm gonna take all the questions. 6A. Okay, sure. But you gotta be careful. You have a root, which is not okay. So the x in the denominator is gonna disappear if you take a if you do that. Yeah, so that might work. I mean, I don't know. It has the root that doesn't quite disappear ever. It just gets worse and worse. Um, the 5 will disappear. So yeah, you could do that since they don't tell you, right, how to do it. Unless they tell you to use, I don't know, they won't tell you. So sure, you can do that. If it's the right form, is it? Sure it is. It's 0/0. So you can use L'Hopital's in 6A. That's not what they were expecting, but yeah. Oh yeah, so we can do 6A. So 6A says limit. So that's the handwritten, right? Handwritten. Minus 6 over x minus 6. So the way that's 5. That's incorrect. So let's see, does that, so if we plug in 6, well, I mean, you always plug in just in case somebody has done a mistake and you're like, oh, please, somebody's did a mistake, so I don't have to worry. So 0. Okay. So if the numerator is not also 0, so maybe we're good. So is it? So it's 18, 25. Okay, it's unfortunate. So it's 0. So here you have an option. You can either break the form by multiplying by the conjugate. You can do that. That's what they're expecting. But, or you can try to use L'Hopital's and hope for the best. Now, notice if you use L'Hopital's, the denominator is going to kind of disappear. It's not going to have excess anymore. But the numerator is going to become weird because the derivative of something to the half, which this is going to disappear when you take a derivative. But this is going to kind of hang out a bit. So, but it will give you an answer pretty quickly if you use L'Hopital's. Yeah, sure. So if you use L'Hopital's, it will give you an answer. That's not what they were expecting. They're expecting that you multiply. But if you were to use L'Hopital's, which you can, then the bottom becomes 1, right? And then the top, this is going to go 0, right? And this thing is, think of it as 3x plus 7 to the half. So you want to take a derivative of that. So the derivative of that is what? Well, 1/2 stuff to 1 less power. So 1/2 times that quantity to the negative a half. So you really have 1/2 root 3x plus 7. Pretty quick. There's no way you get 0/0 now. You can see it. You don't have, if you have a 0, it will be in one place, and it isn't, right? So that's very quick. So I would say yes, L'Hopital's pretty quick here, right? You could also multiply by the conjugate. It will take you a little longer and you have more chances for mistakes. There are more steps, right? So you can do that. Yeah, that would work here. So, and parts B and what was it? Okay, so the parts B and C, are you talking about question 8 or the question we're still talking about? Question 8. Okay, so question 8 from what? From the handwritten or from the other one? Handwritten, okay. So question 8 will do which parts? Which part did you say? A. Okay, so A, B, and something else. A, B, C. Okay, so A, B, C. Okay, so A, I put it there just to stress people out. No. You really need to know the graph of log. The log function, this is the x and this is the y. The log function looks like this. Y is equal to natural log of x. So if you take the log function, so notice the log function has an asymptote. And this is the asymptote. The asymptote is this line. It's a vertical asymptote because the graph comes close to this line but doesn't touch it. So this is the line where all the x coordinates are 0. So that is the equation of the y-axis. X equals 0 is a vertical asymptote for this graph. But that's not the function they gave you. So I gave you give me a second. I don't know what's happening here. Confirm your speaking language. Dear goodness. English. Okay. That was weird. Okay, so if somebody gave you this function, it only has one asymptote, one, vertical one, nothing else. So if somebody gave you this new function, well, how does that differ from that? Is, well, 1 minus the old function. So first of all, they took the old function and they changed the sign. So all the y coordinates, instead of being log of x, they became negative log of x, right? All the y coordinates initially changed signs. So you have some y coordinates that they were negative, and you had some y coordinates that they were positive. So when you stick a negative in front of the log, everything flips. The graph flips around the x-axis. Anything that was below the x-axis goes above. Anything that was above, any part of the graph that was above the x-axis goes below, right? Think the graph flips. So because I have this part in here, in the new function, I'm going to take this graph and flip it. The stuff below will go above, right? So I'm going to take this and flip it above, and take this and flip it below. So the graph is going to go like this. I just flip the graph, right? But I don't have to do just that. Okay, that took care of the negative. I also have to take this new y coordinate at every point and add 1 to each one. So I'm going to take the whole graph and move it up. Okay, moving the graph up or down does not change the vertical asymptote because you're not moving the graph left and right. You still have the same asymptote, right? So this just moves the graph up. The asymptote has not changed. It's still the same. There's only one asymptote, right? X equals 0, the vertical asymptote, the y-axis. So that was like a silly question. There's no horizontal asymptote there. There's just a vertical asymptote. The other two are a little bit more interesting, B and C. So you have this function. So when you're asked to find horizontal asymptote, you really asked to evaluate two limits. The limit of the function as x goes to infinity, and the limit of the function as x goes to negative infinity. And if the answer is a number, any number, 0, 1, negative, whatever, 1,000, whatever, as long as it's not infinity, if the answer is a number, then y equal to that number, because that's the y. You're asking, what is the y doing at the very right when x is going to infinity, and what is the y coordinate, what's happening to it on the very left? If the answer is 4, that means the y is becoming 4. So that means y equal 4 is a horizontal asymptote. That's how you find horizontal asymptote. So in this case, you have the limit as x goes to infinity of this function. That one. It won't change if that was a 5x, but it doesn't matter. The answer will still be the same. But anyway, so you look at this, and you know when x goes to infinity, this goes to infinity, this piece goes to infinity, and this piece goes to infinity. So you have 4 minus infinity over infinity. So you have infinity over infinity. You have no idea what that is. Right? Please don't use L'Hopital's. So what do we do? You can use L'Hopital's if you have infinity over infinity, if that was power functions, like x to a number instead of e, two x's. Don't use L'Hopital's there. So what can you do? You can factor out the e to the highest power, right? So I'm going to factor out. So I'm not using L'Hopital. I'm just factoring out the e to the highest power. So e to the 2x, and I'm factoring out e to the 2x. So on top, so that means I'm dividing the top and the bottom by e to the 2x. So I have 4 over e to the 2x minus 2. And on the bottom, I have 3, because I divide by e to the 2x, plus 5 over e to the x, because there is already 1 there, so I only need to divide by 1, right? So now I simplify, and I evaluate the limit again. Right? The moment you simplify, change something, then you can attempt to evaluate the limit again. So when you try to evaluate the limit, this now goes to what? As x goes to infinity. 0. So that goes to 0, and that goes to 0. This is already 1. So therefore, you have negative 2 over 3. But the question was, find our horizontal and vertical asymptotes. When you're taking the limit as x goes to infinity, if you find a number, the number is not an asymptote. The number is a number. An asymptote is a line. So if somebody asks you for a vertical or horizontal asymptote, you need to give the equation of a line. So your answer has to be x equal to a number or y equal to a number. Y equal to a number are horizontal lines. X equal to a number are vertical lines. So you need to do one or the other. You can't give a number back. You'll get 0 credit, even if it's correct number. So the horizontal asymptote is y equal to negative 2/3. And of course, you can do this on the other side as x goes to negative infinity. There's no reason you'll get well, we get similar stuff. So let's see. No. But so by the way, the exponential function, whether it's y equal e to the x or y equal e to the 2x or y equal e to the any number of positive x's, the graph looks like this. So when x goes to infinity, e to the x goes also to infinity. When x goes to negative infinity, e to the x goes down to 0. The y coordinate goes to 0, right? So if you were to take the limit on the other side, when x goes to negative infinity, this goes to what? Doesn't go to infinity, it goes to 0. So this goes to 0, this goes to 0, this goes to 0. That's not going to give you a constant. 5 over 0 is not a nice number. It's infinity. So there's nothing on the left. That means the graph on the left, there is no horizontal asymptote. But you found a horizontal asymptote. Here it is. Right. So how do you find the vertical asymptotes? So again, horizontal asymptotes, you just take limits. Vertical asymptote, you will have a function that looks like that. So first, in order to find the vertical asymptote, you need to simplify completely, numerator and denominator. So if there's any common factor, get rid of them. Do that first. And when you're done with that, then go ahead and answer the question if there's a vertical asymptote. Don't answer the question before you simplify numerator and denominator. Here, there's nothing to simplify. Really, nothing. So I write this thing. In order to figure out if there is a horizontal asymptote, after I simplify, I take the denominator and set it equal to 0 and find the x. That makes it 0. If there is such an x, that is my vertical asymptote. That line, x equal that number, is a vertical line, and that's an asymptote. Okay, so I'm going to take, there's nothing to simplify, get numerator and denominator. In this case, a horizontal line, well, why would that be a horizontal asymptote in this case? Okay, so to have a horizontal asymptote, either this, to have that horizontal asymptote, then either this is equal to 0 or this limit is equal to 0. One limit was negative 2/3, whatever we found. The other limit on the other side, this one to 0, this one to 0, this one to 0, so it gave you 4/0. That's not 0. Right? So no asymptote on that side. Okay. Right, so I'm going to take the denominator, set it equal to 0. If there is an x that makes the denominator, again, but you do this after you simplify. So if there's any x that makes the denominator 0, x equal to that number is a vertical asymptote. So I'm going to take this, set it equal to 0. I factor it if I can. I can take an e to the x out. So I have 3e to the x left plus 5. This quantity is equal to 0 if e to the x is 0 or the other stuff are 0. But one thing we know about exponential functions is if this is the exponential function, the y-coordinate e to the x, the y-coordinate is never 0. So this is never 0. Never. Not only that, this thing is never 0, and also this thing is always greater than 0. You can see all the y-coordinates are above 0. Right? So if you're trying to find what x makes this quantity equal to 0, you can try to solve it. And in order for an x, such an x to exist, it must be true that there is an x that makes e to the x negative 5/3. That's not possible because all the e to the x's, the y coordinates, are not negative. So that's not possible. That's not possible. There's no vertical asymptote in B, but there is in C. In C, the process is the same. So horizontal asymptotes, you look at the limit as x goes to infinity and the limit as x goes to negative infinity. And if you get a number, you simplify. So if the numerator was, let's say, that, and the denominator was that, I will not take this and set it equal to 0. Your first job is to simplify this, right? Even if the numerator is not 0, it doesn't matter to me. I would simplify this first. So, right? So factor this, and if there's any common factor, I need to get rid of it before I consider that in the denominator, right? So this would give you, if I forgot this, completely ignore the numerator, it will give me 2 vertical asymptotes, and there are not 2 vertical asymptotes here. There's only one. So it will give me x, what is it, plus 2. Okay, that's backwards. No, that's correct. It will give me this, right? Right. So, and then I will say, oh, I have 2 vertical asymptotes. And the answer is, no, you don't. You don't have this one. Because if you bother to factor top and bottom and simplify it, you will never see this one. There's only one. Okay? So the thing that you found cannot make the numerator 0, because if it did, you didn't do your job simplifying. Anyway, so that problem I want to mention. C looks like this. x goes to infinity, what you can do, a quick way to work this out, since x becomes larger and larger, what matters really in the numerator are the large things, the things that will get larger and larger. So really, this term is the only term that matters, because x will get huge. The 4 will be meaningless, right? Who cares if you have a 4 when you have like gazillion next to it? So the same thing with the 5. Negative 5 means nothing because this is going to become ginormous. So what's one way to think of it? That this is really, because x goes to infinity, this is really the same, really, not approximately. It's really going to be equal to the following thing, the limit of 2e to the x over 3e to the x as x goes to infinity, which is clearly 2/3. Another way to think of it is to say I'm going to factor out the e to the highest power, so e to the highest power, and I'm left with 4 over e to the x plus 2, and then e to the highest power, and I'm left with 3 minus 5 over e to the x. I get rid of these, that goes to 0, that goes to, that goes to 0, that goes to 0, and you're still left with 2/3. Either way, you're left with 2/3. As x goes to infinity, what matters again in the numerator is the term that becomes the largest, has the largest value, absolute value, and the same thing with the denominator. In the other case, as x goes to negative infinity, this guy goes to 0. This guy goes to 0 because e to the x looks like this. So when x goes to negative infinity, e to the x, the y coordinate goes down to, you can see it goes down to 0, the y coordinate. So that goes to 0, so the answer is 4 over negative 5. So in both cases, you get constants. You're looking to find out what the y coordinate is doing at the edges. The y coordinate at one edge is becoming 2/3, and the y coordinate on the other edge is becoming negative 4/5. So you have two horizontal asymptotes, y equal to 2/3 and y equal to negative 4/5. Two of them. Okay. And you also have, in this case, a vertical asymptote, because again, you can't simplify numerator and denominator, but you can take the denominator and set it equal to 0, and you can get an x that will do that. So what's x? Right. That's a vertical line. That's your vertical asymptote. So you have two horizontal asymptotes and one vertical. Make sure you know how to do that. It's a good problem. What was the other question? No limits there. Nope. No. There's no reason. No. Just make sure you simplify, take the denominator, set it equal to 0, and you're fine. Actually, hold on. Let me see something. I don't have it with me. No, you don't. It's fine. Yeah. What was another question? I don't remember hold on, let me find out what the other questions were. I don't remember. Domain and range. Okay, what about the domain? For this function, you mean? Well, that's the thing about vertical asymptotes. Vertical asymptotes you have where an x is so bad and is so not in the domain that the function is so frightened of it that it doesn't just go like, like this x. Yeah, okay, I don't like it, but I'm just going to go through it. That's an x not in the domain, but it's not very bad. Right, so this x is also not in the domain. But then you have this other x where the function is so scared of it, it's so not in the domain that the function really bends to avoid it. It's like, no way, I'm not going to come close to that number. I'm getting close to it, but I just completely bends. And the other way too. On the other side, the function either goes from this direction or the function comes from this direction. Again, tries to avoid that x. So yes, the x where you have a vertical asymptote is an x not in the domain, clearly, because it makes the denominator 0. Um, 15. There's a 15. Oh, I updated it. Shoot. Okay. Hold on. Give me a second. Oh, that one. Yes, 15. Let's do 15. Okay, so 15 is good. It's a good problem. The handwriting is like, what is that? I can't read it. Okay, so you have a function that contains the so if somebody says these points are on the function, you better show them. You can't say, well, that doesn't fit. The blue one that I've highlighted doesn't fit, and pretend it's not there. You need to include it, right? So -2, 3 is part of the graph, 1, 2 part of the graph, 4, -2, yes, 6, 1 are all part of the graph. Okay, so these are points. Also, the function is continuous everywhere, except at x equal 4. So here, there's an issue. There's a jump. Just because the function is not continuous at 4 doesn't mean x equal 4 is not in the domain, right? I can make a function not continuous at 4, right? I can make a function not continuous at 4, not continuous at 4, and then I can stick a point that has a 4 as coordinate. But the function is clearly not continuous at 4, right? So I can do anything and still include a point with an x coordinate 4. Okay, so also tells you that the limit of f as x goes to 4 from the left is equal to infinity. So that means that tells you you have a vertical asymptote. So that tells you if this is 4, see, x approaches 4 from the left. If you're coming from this direction, the graph bends up, turns up, tries to avoid x equal 4. So the graph bends this way. That's what that tells you. Okay. Also says the limit of f as x goes to negative infinity is equal to 5. So this tells you that if you go to the left side of the graph, so the graph does all kinds of weird things. Eventually, on the left side, when it settles with the weird stuff, it settles to a height of 5. So the graph settles at a height of 5, either from above or from below, coming to a height of 5. That means you have a horizontal asymptote on the left side. Right? The graph settles at this horizontal line. Okay. So somehow I'm going to bring all these things together. It also says that the derivative is equal to 0 at x equal 1 and x equals 6. So that it doesn't say it's not 0 anywhere else, right? It's 0 there. So derivative is 0 could be because the graph does this. The derivative is the slope. Or the graph does this. Or the graph does this. Still kind of flattens out. So the derivative is this. The tangent line is horizontal, so the derivative is 0. Or it does that. So there's some flattening out happening. That's what it's telling you. At x equal 1 and x equals 6, more likely there is a little bump, but you don't know. We'll see. So you really have to go by what comes next, which is that table. So the table has from negative infinity to -2, from -2 to 1. This is the x-axis. From 1 to 4, from 4 to 6, and 6 to 8. To infinity, not 8. So the derivative, and here's the second derivative. The second derivative tells you how a graph bends. If the second derivative is negative, the graph bends downwards. If second derivative is positive, the graph is concave up, bends upwards. So you have negative, negative, positive, negative, positive, and then you have mostly positive. So this positive stuff tells you the graph bends upwards, but you can draw now the graph just right underneath, like semi-draw it. So negative derivative, that means the graph goes down and it's facing down. So it goes like that. And then continues to go down, but facing upwards. So continues to come down, but bends the other way. And now it comes up, continues to bend upwards. Right? So the graph goes like that, continues like that, comes up, and then it comes down all of a sudden, right? This is a continuous function. So all of a sudden, look what's happening at 4. We already know at 4 there is an issue. There it is. The graph goes up and there's a vertical asymptote. So you probably are doing something else on the other side of it, right? So the graph goes up, sure enough. And then you're doing something else on the other side of it. What are you doing? You're coming all of a sudden down. So here's your x equal 4. So there's a break there. You can see it. And then you go up again facing up. So you go continue like this. So you have something that looks like a parabola to the right side of 4. And then before 4, you have this thing happening. Come down, go up like that. Right? And you're told that as you're moving to the left side of the graph, if you're moving to that side of the graph, on the left side, you're settling at a height of 5. So now you can position the graph. Okay, first find the points they gave you. So position those points. So you have -2, 3. How high up does it go? 6. Oh, that's unfortunate. No, 3 is the highest. Okay, so 1, 2. Let's do 1, 2, 3. Let's pretend 5's here. So here's a point on the graph, and you also have 1, 2. Here's another point on the graph, and then you have 4, -2. So this is 1, 2, 3, 4, -2. So that's here. This is where the asymptote is. And then you have 6, 1. So 6, 1. So you also have this point. So these are points you have to go through, right? You also notice that the derivative, second derivative, change the sign here and nowhere else, right? So at this point, at x equal -2, you have an inflection point. So you need to show on the graph, here it is. The graph turns downwards and then turns upwards. Here's the inflection point, x equal -2. So -2 is right there. So the graph goes from facing downwards to facing upwards. Goes like that, right? And it doesn't do anything else strange here. It just keeps on coming closer and closer to 5. Let's pretend that's 5, right? So what else? It goes down all the way. The bump happens at 1, right? You see the graph goes down and then comes up again. That's where the bump happens. This is x equal 1. So I need to fix this. So the bump happens here. So I go down, facing up, and I kind of make the bump there, right? So I would say definitely come with a pencil, not with a pen, something you can clearly erase, right? Have an idea what the graph looks like. It would look like this, and it will have a vertical asymptote and then a little parabola on the other side, or something that looks like a parabola. Doesn't have to be, right? Here's your asymptote. So here's this piece of the graph. And then the other piece of the graph will come at this point, which is the point 6. And at 6, notice that's where you have another bump. So I'm going to do the bump here like that. So now I have all the points. I have 1, 2, 3, 4 points that they're given, and I have the graph. Yeah, it's not on, it's only on the, it's not on the right side. Notice, not on the right side. Don't assume you have an asymptote on the other side. First of all, you definitely don't, because if you did, this wouldn't be going up like this. It would be going up facing down. If it becomes asymptotic, it better turn, be concaving down. It's not, it's concaving up. So it has to continue straight up. Oh, yes. So, okay, so we do understand why this doesn't have any more asymptotes here on that side, right? If it had to turn and become asymptotic, the derivative, the second derivative will be negative. It will be turning, it will be bending the graph. So again, for which asymptotes? No. So no. The point of 4, no, it's a vertical. A vertical asymptote doesn't mean the graph doesn't have a point there. A vertical asymptote means something horrible happens to the left and to the right as you're approaching 4. This guy is not approaching 4. He's already there looking at everybody around them. It's like, what are you guys afraid of 4? All right, he's there. Asymptote, it says what's happened to the graph as it's trying to come close to 4. When you're trying to come close to 4, you're not here. You're either on this side or you're on this side. And look what's happening on the graph as it's coming close to 4, is frightened to, and stays away from x equal 4, right? Yeah, so that doesn't mean there's no point there. No, a line doesn't cross it, but you could have a point there. The graph can't cross it, but there could be a point there, right? The graph won't cross it. If it crosses it, there's no asymptote. The graph is not afraid of it, right? The graph won't cross it. So like to the left and to the right, it won't go through it, but there could be already something there. Yes, not continuous doesn't mean it's not in the domain. Exactly. Not continuous means that you could have a jump, either a big jump or a little jump. That point could still be part of it, of the domain. Okay, so there was some question about asymptotes. What was it again? Oh yeah, so specifically here's, so I want to mention this problem again one more time. So for horizontal asymptotes, you're asked to find two limits for horizontal asymptotes. Horizontal asymptotes look like this. Y equal to a number. An asymptote is a line. You can't write a number. You have to write a line. Either x equal to a number, that's vertical, or y equal to a number, that's horizontal. So as x goes to infinity of this h. And you also have to find the limit, as I said, as x goes to negative infinity of this function. Now, e to the x, e to the 3x, e to any positive number x's looks like this. Well, you'll see it not exactly like that. Some of them go up faster, but they kind of look like that. You won't notice them if you just see one and then you see another one separate. You'll think it's the same thing. It's not. But anyway, they kind of look that way. So as x goes to infinity, e to the x, which is another way of saying what's the y coordinate you're doing, e to the x, the y coordinate, also goes to infinity. Okay? as x goes to negative infinity, e to the x, which is the y coordinate, as x goes to negative infinity, e to the x, the y coordinate, is going to 0. Okay, so e to the x is going to 0 when x goes to negative infinity. So when x is going to negative infinity, e to the x goes to 0, e to the x goes to 0. So this is equal to 4 plus 0 over 0 minus 5, which is equal to negative 4/5. Since the limit as x goes to either positive or negative infinity was a number, there is a horizontal asymptote y, which is the function y equal to this number, is a horizontal asymptote. So now you have to do the same thing on the other side. On the other side, as x goes to negative infinity, to positive infinity, as x goes to positive infinity, e to the x goes to infinity. So this is 4 plus infinity over infinity minus 5, which is like infinity over infinity. You could use L'Hopital's if you want to here. If you want to, that's fine. You can use it. Actually, it would be pretty easy to use L'Hopital's here. It might be the best. Or you can factor out the e to the highest power. So since I already did it one way, I'm going to do it the other way. So you can use L'Hopital's here because this is infinity over infinity. So you're allowed to. So that will go away. That will go away because the derivative is 0. So the derivative of 2e to the x is what? What's the derivative of this numerator? Yeah, 2e to the x. And the derivative of the denominator, the 5 goes away, it's just e to the x. So notice this is pretty straightforward. It's 2. Wait a minute. Yeah, correct. It's 2, right? So again, a number. If the limit of f as x goes to infinity or negative infinity is a number, a constant, any number, 0, any number, positive, negative, then y equal to that number is a horizontal asymptote. So you have one horizontal asymptote on the left, and you have another horizontal asymptote on the right. So you have two horizontal asymptotes. So if they ask you what are the asymptotes, horizontal asymptotes, you'll say 2 of them. Y equal 2. You're not going to say 2 and negative 4/5. These are not asymptotes, these are numbers. An asymptote is a line, it's an equation of a line, right? So these are the horizontal asymptotes. Vertical asymptotes, you will take your function that's going to be fraction. You're going to simplify top and bottom as much as possible. And then you're going to find, when it's simplified, this thing. Just simplify. You can't simplify further. So what are you going to do? You're going to take the denominator and set it equal to 0 and find the x that makes the denominator 0. That x equal to what number? That equation is the equation for the vertical asymptote. So again, you take this, set it equal to 0. This is your vertical asymptote. That means this x is so bad that is so not, well, it could be in the domain. It's just such a bad x, the function doesn't really want to go through it. And as it's coming close to it, it just goes out to infinity or negative infinity. It tries to really avoid it. It could be in the domain. In this case, it isn't, though, right? In this case, it isn't because it makes the denominator 0. In this case, it's not. Anyway, okay. You need to for horizontal asymptotes. You don't need to for vertical asymptotes, but you need to for horizontal asymptotes. Okay. Okay. What was there was some other questions. Number 13 on the final review. So hold on, number 13. So 13 is the one with the So 13 is the one with the parabola and the line and the sketching and the setting up integral. Is that what you're talking about? Is that the problem? Yes. All right. So hold on. Give me a second. That's unfortunate. Okay, so you should find something. I'll do it in a minute, but you should find something that was slightly more appropriate. Where is it? Okay, it's not here. Okay, so there should be something in the notes, in the lecture notes. You should look at that problem. That looked like this, right? So that's similar to that. I'll do this. So that's a similar problem. So let's see what this one says. So number 13 has a parabola. So this is a parabola that opens, this is positive, so parabola opens up. The vertex, it's going to be opposite of this number and exactly this number. That's the vertex. So the vertex is -2, -3. That's the vertex. And it goes up because this is positive. So this is a parabola that goes up with a vertex at -2, -3. Okay. And then you have this line. So this is the y-intercept. And it goes up because this has a positive slope. So the line goes like that, right? So in order to have some region, this line must intersect. And it can't just intersect there because then you have no region, right? It must intersect somehow like that. So you really want the 2 points of intersection. You don't care where the axes are, really don't. Because if you do, you might just lose your mind trying to position it correctly. So let's not worry about the axes. Let's figure out the points of intersection and draw this thing. So, so points of intersection. So we're intersecting y equal the line to y equal the parabola. So the y's are equal where they intersect, right? So I'm going to set the y's equal to each other. I'm going to take the weird y's first. Please write nicely on the exam, not this handwriting, better. So I'm going to expand this. So x squared plus twice first times the second plus the second squared minus 3 is equal to 2x plus 4. I'm going to get rid of the 4's because they're everywhere. And I'm going to bring everything together. So I have x squared plus 4x minus 2x minus 3 is equal to 0. And then I'm going to factor it. What were we doing again? We're finding the intersection points. So you can, if I find the x, I can go here and find the y, or I can go here. I should get the same y, right? I'll go here because that's easier. So this is factorable, right? So you want two numbers whose product is negative. So one's negative, one's positive, but the positive wins because it has a larger absolute value. So it's going to be plus 3 minus 1. So they intersect at -3 and not 1. So this is 1 and this is -3 in the x. So if I want to know the y, when x is equal to 1, the y is 6. If I want to know the y here, when x is equal to -3, y is a lot. Well, no, that's not true. That's -2. So these are the points. So I'm going to do it again. So here's the one graph. Here's the other graph, 1, 6, and -3, -2. And the vertex was opposite of what you see there and exactly what you see there for y. 2/3. For which problem? Which problem was it that we just did? That you said 2/3? But that was from my handwritten notes, right? Did I say something else there in the handwritten notes? Hold on. No. Hold on. Which problem was it? 6. So 2/3 will be for, yeah, 2. Oh, did I not write the 3? Okay, anyway, so for my handwritten notes, it looks like it's correct what I have there. So I can come back to it. So let's see. Oh, I forgot the negative. No, I did not forget the negative. That's correct. That's log of 5/3. That's correct. Oh, I don't have both horizontal asymptotes in that problem. There are 2 horizontal asymptotes, and I only have 1 in the solutions. But anyway, I'm going to come back to it. So the solutions are not complete. Number 8. Yeah, that's number 8. Yeah, I'm looking at it. Anyway, so yeah, so it's missing 1, right? And I don't have solutions to all of them. I only have solutions to like a couple of problems there, right? So I can come back to it later. But anyway, so here's the graph, right? Now, if you want to position the axis, okay, so let's look at the y-axis. So you have a y-axis. Where can I put it? Well, I want to put it, let's see. So this is the y, this is the y, and this is the y. So the y goes from -3 all the way to 6, right? The x goes from -3 all the way to 1. So this axis has to go here somewhere, right? Because the x goes all the way to 1. So something must be to the right of the y-axis. And there's a lot to the left of the y-axis because x goes all the way to -3. And now you can position the x-axis. Well, how do you position the x-axis? Well, the y-coordinates tell you where to position the x-axis. The y here is very positive, and it goes all the way to very negative, right? Here is already negative, so then so the x-axis should be here somewhere, right? You don't have to be exact, right? Okay. So anyway, you don't really need the axis in order to set up the integrals you're asked to set up. I'm gonna get rid of this. I don't need it. Go away. All right, so how do you set up the integral? Well, one way to do it is set up using an integral with respect to x, and another one using an integral with respect to y. So if you want to do an integral with respect to x, what you're putting here is a difference of y coordinates. That means you take a y coordinate and subtract a small y coordinate. So that means you put a line segment that's vertical. So if you put a line segment that's vertical inside your region, sure enough, the length of it is a change in y coordinates. So you're integrating a change in y coordinates. The width of it is your dx. Okay, so no matter where you put the vertical line segment, the top part of it falls on the line, and the bottom part of it, no matter where it is, falls on the parabola. So that means you require only one integral. So you have the top y, the large y, minus the small y, the bottom y, right? That's what you're integrating. And this line segment can go far to the right, or you can go very far to the left. On the left, x is equal to -3, and on the right, x is equal to 1. So it goes from -3 to 1. And all you have to put is now the y coordinates. The y coordinate on the top is the y coordinate on the line. That's the top. That's what's going to go in place of y top. So you go from -3 to 1, y top, which is 2x plus 4, minus y on the bottom. The y on the bottom is part of the parabola. So x plus 2 squared minus 3. So this is what we integrate. If you do it the other way, with respect to y, that means here you have to have a change in x. That means your line segment is horizontal. Its length is changed in x coordinates, so the line segment is horizontal. But if you put the horizontal line segment in here, let's put it here. As you're moving it, the left part of it jumps. So if you move it too much, the left part jumped to a different graph. Okay, so that means you need to use two integrals, one for the pink part and one for the green part. So for the top part, for the pink part, again, you're integrating the change in x, because the change in x is the length of the line segment, because the line segment is horizontal. And its width, it goes up and down. It's how fat it is, right? That's your delta y. That's what you're integrating with respect to. So on this pink part, the y's go from this y to that y. The bottom y is -2, the top y is 6. So it goes from -2 to 6 on the pink part. And on the pink part, the line segment has length the big X minus the small x. The big X is on the parabola, the small x is on the line. So since this equation looks like that, the x is equal to 1/2 y minus 4. That's what the x is equal to. That's the small x. So that's going to go here. Small x is 1/2 y minus 4. Okay, that's what you're subtracting. The big X is the x on the parabola. So now you have to write the parabola and solve for x. So when you write the equation of the parabola and you solve for x, you get, when you get rid of this square, you get the plus or minus on the other side. And now when you solve, you have x is equal to -2 plus or minus root. And that tells you every time you have a parabola, whether it's upside down or this way, which doesn't matter which way, the x's that have the plus are the x's that they're larger. These x's have the plus. The x's that have the minus are the x's that they're smaller on the left side of the vertex. So these are the x's that have the minus. Okay. Now this x's on this side are the larger x's because they're on the right side of the parabola. So the large x is this x. So that's going to be -2 plus square root y plus 3. That's a plus there. So this is one integral. But you also have to add this area, right? And this area is given by the other integral, where the y goes from this y, which is part of the vertex. That y was -3, all the way to the y here, and the y here was -2. So it goes from -3 to -2. Notice it continues later on. This number is the same. And again, you're subtracting the x's and integrating with respect to y. So for the bottom, you're going to do the same thing. You're going to take the small x and subtract it from the large x. The large x is on the parabola, the small x is on the parabola. So you subtract the two x's on the parabola. You take the large and subtract the small. So the large and subtract, don't forget the parentheses, the small. I really don't bother simplifying this even. So that is the integral you're going to set up. You will have to set up exactly this type of thing. Do it twice. And in one case, you'll have a sum. I want to go back because somebody said something. So I want to go back to this this problem here. Yeah, so there were two, where are they? There were two asymptotes here. Why write 2/3? Why is that 2? Oh, that's because, okay, because, right. I pretended that was an e to the x. It's not. I forgot there's a 3e to the x, and I thought 3 to the x means e to the x. Weird things happen, and I'm not even taking an exam. So if that was an e to the x, the answer would have been correct. It's not an e to the x. It's a 3e to the x, so the derivative is 3e to the x, so the answer is 2/3. Okay. Yes. Okay. What? I'm not sure what you're saying. So when we're doing horizontally, he do it in, what do you mean? In the solutions? I haven't looked at the solution. What is he writing? Hold on, let me look. I haven't looked. Did he do something weird? Okay, so in his solutions, he's very talkative guy. His solutions reflect it. He says all these things that you really don't want to write in the solution. So don't worry about it. I'm gonna look. I'm gonna look because I'm worried. But don't worry. I will look at every grading that's done on your paper eventually. Give me a second. Where is it? Okay, yeah, it will take a little time because I have a new computer. I have no idea how to use it. Teaching. Okay. Let's see. No. That was problem. Let's see. Does he have something like that there? I don't remember him. Oh, he does. Oh, he does. He does. Okay. Oh, he takes a limit. No, you don't have to. I see. So this is to verify. So, right. So you don't have to, but I will check. I will check the exam. I'm pretty sure you don't have to, because unless the exam specifically says so, it doesn't. So if you have a function, what's the function in this problem? Oh, and he didn't on the other one, did he? Did you do very concept? Right, he did not do on the other one. Okay, why didn't he? I wonder. Whatever. So you have this function. And so this is why I call that. And you want to find the vertical asymptote. So again, Simplify top and bottom. Well, there's nothing there to simplify. This is not factorable. Top is not factorable. Bottom is not factorable. There's nothing you can do. So you take the bottom, set it equal to 0, and solve for x. Just remember that this is not 0 ever. In fact, this is always greater than 0. So if you're finding e to the x must be negative, stop. There's no x value that she can find. So here I can work this out because negative 4 e to the x is equal to negative 1. That means e to the x is 1/4. That's good news because it has to stay positive. It is. So now you can continue solving. So x is natural log of 1/4, which can be simplified when we don't bother. That's enough. Now, if somebody says, prove it to me, they're not going to ask you to do that. If somebody says it won't be proved, like show it to me that this is actually a fact, then okay. Then you can say, let me explain to you why this is true. Because as you're going to this number, seriously, nobody's going to ask that. This function, something happens to it. Okay, he's not going to ask you that. The answer is going to be plus or minus infinity because it will take you some time to figure out, is it plus or is it minus infinity? Not sure, right? So do not worry about that for vertical asymptotes. Vertical asymptotes simplify numerator and denominator if possible. In this case, it won't be possible. Take the denominator, set it equal to 0, and solve for x. And write the answer x equal to that number as your vertical asymptote. That will be enough. Okay? I guarantee it's gonna be enough. One of the reasons is nobody wants to grade this. It can get messy. 12C. Can we do what? 13C. Number 6 on the review. Okay, how many problems are there? Okay, 4. Okay, give me a second. This is 14, 15. Number 6. Okay, so number 6 on the review. What's number 6? That one. Yeah. What does it say? Observer. Okay. So you have a balloon, I guess. I guess this keeps on changing because the balloon keeps on going up. This stays constant. There's a similar problem in the handwritten review. Do that as well. And then you say it lifts off, go straight up at the rate of, so since the balloon goes up, is the rate of change of y positive or negative? Positive, right? If we had the case in the other problem, we have somebody, here's you, like huge arms, that means you have big muscles there, and you're pulling this rope that has this boat. Dear goodness, has this boat. So if that was y, what kind of number is the rate of change of y? Positive or negative in this case? Negative in this case, because if you're pulling it, this is coming this way, but this is getting smaller and smaller and smaller. Okay, you're pulling it, it's getting smaller and smaller. Okay, the problem, regardless of whether it's positive or negative, it will give you a positive number. But you need to know from the picture whether this quantity whose rate of change you're given is getting smaller. If it's getting smaller, you're going to write that rate of change with the correct sign, positive or negative. In one case, it's positive. The other case was negative. Anyway, so this is positive. What is it? 50. So in this case, it's 50. The units, we don't care until the very end when I'm supposed to answer something. Then I worry about what the units are. So you stand there 80 feet away, whatever. So D is the distance. What's D? D is this distance. So the balloon is going up and Here's a person who's looking at it. Okay, so of course, the rate of change of D is it positive or negative? Here's a balloon flying, going higher and higher. So the rate of change of D is positive, right? Because D is going to get larger and larger, right? The distance from the observer to the balloon is getting larger and larger because the balloon is flying away. Okay, so fine. So that's the story. And then, so assume times in minutes, whatever. So find the exact value of dy dt. Okay, so what is dy dt? 50. Okay, so it's not very difficult here because it is positive as it's given to you. If that was a similar question here, they would still say 50, but you need to write negative 50 because this value is getting smaller as somebody's pulling the boat, right? So in this case, it will be 50. It says find the exact value. It doesn't say what the quantity is, so I don't have to worry about units. But if I were to write the units, I would write the distance units over time units, so feet per minute. So 50 feet per minute. So write the equation that relates D and Y. So we have this picture. So I want to write the equation that has only D and Y as the unknowns, no other unknowns. So clearly I'm going to use Pythagorean theorem. That says the square of the hypotenuse is equal to the sum of the squares of the two legs. So y squared plus 80 squared. That's it. They're not asking you to get rid of any square powers. Just leave it alone. So that's what it is. That's the equation that relates the two. It doesn't say solve for D. So I'm not going to. So, and now they're asking you what rate is the distance between the person and the balloons changing. So they're asking for the rate of change of D. Here's the person and here's the balloon. So they're asking for dt, dd. That's terrible. dt. So you have this equation. So what are you going to do? Take the derivatives with what? With respect to t, to time. So the derivative with respect to t of the left side is equal to the derivative with respect to t of the right side. So this is why you don't really want to bother doing 80 squared. Why? Because when you take the derivative, it's going to go away. Right? So you wasted your time multiplying 8 by 8 and then by 100. So don't do that. So the derivative here is 2d d prime, or let me write dd dt, right? So again, there are t's, little t's, inside this capital D. So this is a function that has other little stuff inside it, time. So when I take the derivative, when I look at d squared, I'm thinking of stuff squared. The derivative, I'm going to use the chain rule, 2d times the derivative of d. So the same thing I'm going to do here. 2y times the derivative of y. This I know, the 2's can cancel. I really want to solve for dy dt. So dy dt is equal to d and the derivative of d divided by y. This I'm given. It's 50. I need to find d and y at that moment of time. So they're giving me one of them. They said the height of the balloon is 60. The height of the balloon is this thing. They're saying this is 60, so I know what y is. I know what the derivative is. I still want to find d at that moment in time when y is equal to 60. I want to find what d is. Okay? And I already know this is 80. So again, I'm going to use the same equation to find d and plug it in here, right? Because I need to figure out what this is. And that will give me the derivative. So again, d squared is equal to y squared, which is 60, plus 80 squared. So d, clearly it's not going to be positive or negative. It's going to be positive because it's a distance, right? Positive root 60 squared plus 80 squared. Does it simplify? Sure it does. because you have 6 squared, which is 36, and 100. And then you have 8 squared, which is 64, and 10 squared, which is 100. So 100, 36 plus 64, which is another 100. So it's 100. Now, don't simplify in the exam. Who cares what this number is? Just put it as is inside here and put the correct units. What are the units? The y units, distance over time. So feet per minute. Now, you don't have to simplify this. And it better be positive. It is, right? Because the y keeps on getting bigger and bigger because the balloon keeps on going away, right? And then they're asking this terrible question about theta. So you have this person is fixed, is not moving. This point is fixed, is not moving. That's why this is always 80. What changes is this distance, right? So this distance changing from this to bigger and bigger and bigger, right? So as the distance changing, they're asking you about the rate of change of theta. And they're asking to tell them what can you say about theta? Is this positive? If it's positive, that means theta gets bigger and bigger, right? It gets bigger and bigger. If it's negative, theta gets more and more skinnier. If it's 0, that means it always stays the same. There's no rate of change. The theta is always the same, regardless of where the balloon is going. Nobody believes that. Or maybe we don't know. We can't tell from the picture, right? Now, does it say to find theta? Did it find that? Yeah, no, it doesn't say. So you don't really have to, you can explain. I don't think you have to worry too much about the explanation here. So here's a moment in time. So I'm going to move this and make it larger, like way larger, to get an idea what happened to theta. Oops. Do you think this theta is the same as that theta? Is it smaller or is it larger? How did it change? What does it look like? Definitely smaller. So what do you think is the sign of this derivative? It's negative. Now, I wouldn't worry about that. You could talk about tangents and things like that. I don't know what he did there, but this is not a question that's an exam question. So again, why is that? Because there's so many different answers. It's very hard to write one rubric on this, so I wouldn't worry about that. But clearly it's going to be negative because the angle is getting smaller and smaller, so d theta dt will be negative. Okay. Don't worry about this part of the question. This part. Yes, but do the other question that's similar to that in the handwritten notes. Do that one too. Questions? Or was something else? I don't remember. Q6. Did we do Q6? No, that was it. I know there were some other questions I forget because the people writing a lot, so I don't want to scroll too much. So 12C. So 12C in the all sections thing, right? Is that the one? Is there a 12? Oh, there's a 12C. Review 1. Yes, so review 1. That's the same one as the all sections. So 12C looks like this. Okay. So if an int, right, so if that's the one, right, Rayhan? Yes, okay, good. So if an integral is not straightforward, that doesn't seem straightforward, right? Nobody told you to memorize this particular formula for an integral. So what do? Well, you use substitution, right? So if that would have been easier if you had something like this. Well, we know what to do there. You just expand that, multiply, and then use the power rule that says x to a power, as long as the n is not -1, is, we know how to find the integral, right? You could even do that even if that was 2 quadrillion. You could do it. I mean, it will take you the rest of your life, but you can do it. You can just expand it, right? The difficulty is because the power is a half. You can't expand. So that's really, really bad. You can't do this because there's a root there. So you can't expand it. So you want to fix that. You don't mind having a root if it was the other way around. If there was 2x whatever, and that had the power 3, and the root was on this guy, that wouldn't be a problem, right? Why wouldn't that be a problem? Because the 3 here, you can still expand that, no problem, and then multiply by x to the 3/2. So it's not the root really that's an issue. It's the fact that inside the root you have 2 terms. That's the problem, right? So the fact that there are 2 things inside the root, a sum, or in this case, a difference of 2 things, that's the problem. So you need to take those 2 things and make them 1. That's your u. That would allow you to take that and say, that's u. That's one thing, right? So you're going to take this root, what was it again? X to the third, 2x squared minus 5. Take this thing and call it u. So du is going to be the derivative times dx. The d's should have d's. So 4x dx, right? Okay, so if you see an x dx, do I? Well, I do. I see more than that. I see an x and a few more x's dx. So I'm going to rewrite this. I do see an x dx. I take one away from here. I also see a root. And I also see 2 more x's, right? Here's my 3 x's. So the x dx is going to be replaced by 1/4 du. So this thing is going to go away, and in place of it, I'm going to put 1/4 du. This is going to go away, and in place of it, I'm going to put u square root, which is the same as u to the half. And then this is going to go away, and don't know what to put in place of it. So I need to figure that out. Where do I go? To the substitution that told me how to replace x's by u's and u's by x's, right? So I'm going to go to the substitution. What do I want to know? What x squared is equal to in terms of u. So I need to solve for x squared. So 2x squared is equal to u plus 5. So therefore the x squared is going to be replaced by 1/2 u plus 5. Do not distribute the half. There's no reason to do that. So this guy is going to be replaced by 1/2 u plus 5. So I'm going to put everything together. That, this thing, and then this thing. So that's my new integral. And there are no limits. Good. Okay, so any constant factor, I'm going to take it out. 1/2 times 1/4, it's 1, 2 times 4. Do you have to multiply? No, just leave it. Just don't write 6. And then I have the rest, u plus 5, u to the half du. That I can distribute because the square root only has one thing inside it, has a u, so I can distribute now, right? So I have u times u to the half plus 5 times u to the half. Outside, I have something, du, The power here, I add the power, so it's u to the 3/2. And now you can integrate very slowly. So u to 1 higher power divided by the higher power plus 5u to the 1 higher power divided by the higher power. Please don't simplify, but do put the plus c and now go back to x's. So you can leave things as they are here. With a half plus 1, 3/2 plus 1. Don't simplify those. Just replace all the u's by, give me a second. Okay, thank you. Oh, no, no, leave it. I'm still drinking that. Thank you. Okay. So u was 2, what was u? 2x squared minus 5. So you need to take all the u's and replace them by 2x squared minus 5. So 2x squared minus 5 to the whatever this number is. Again, don't have to simplify. 2x squared minus 5 to whatever that number is, divide by that number plus c. Okay? Okay. So any other questions? I don't remember through what other questions were. There were some questions. 3. Okay. Yeah. So if there was an integral where you have to use geometry to evaluate, unfortunately, you're not going to be told that. Now, this particular integral, you can't use geometry. You need to use substitution. But there are other integrals, like this type, that, yeah, require substitution, but not the type that we're learning. Require trig substitution or hyperbolic substitution. Right? No idea what that is. Right. So you can't do those. So the only way for you to do these, well, this you cannot do, period, because geometry won't work. But in order for you to do these things, this type of things, you need to use geometry. Substitution won't work. Not the u substitution won't work. So this is what you have there. And of course, if you're going to use geometry, you need to have limits. You do. You have limits. So here's 1, right? So you need to know what area that measures, right? So, well, this is y. So y is equal to that. Clearly, y is positive or 0. It can be negative because there is no negative in front of the root. So I remember that y is greater or equal to 0. So when I square both sides and I bring the x and the y's together, I see this is the equation of a circle, only it's not the whole circle because I only need to take the part of the circle where y is not negative. So I'm going to take a part of the circle centered at the origin with radius 3. But I'm only going to take the top part of the circle because it says the y has to be square root. It's not plus or minus square root, right? And do I take the whole top part? Well, the x's will tell me. Out of the top part, take that part that goes from x equal negative 3 all the way to x equal 3. So sure enough, you do take the whole part. So this measures the area of the top part of a circle. And we know the area of the circle. So the top part is just half, right? The area of the circle is pi radius squared. And you're taking half of it. So that's going to be 1/2 pi radius squared. Well, because it says square root, that says y is not negative, because y is positive square root. If it says y is equal plus or minus square root, if that was plus or minus, it's not going to be. There's no such thing. You can't put plus or minus inside that. If it said minus square root, then it takes the bottom part of the circle, because y is negative there. Then it will take this part. Okay. But remember that a definite integral is not necessarily area. It's signed area. Signed area. So yeah, if it's square root, it's half a circle. Yes. Or a quarter of a circle. So here's one with a square root. So if I do this, already you know you're supposed to take only this part. If this goes from -3 to 3, yes, you're taking the whole top part. But if it doesn't, if it goes from 0 to 3, out of the top part, you only take the part that x goes from 0 to 3. So you only take a quarter. So you already start with half, and then the limits will tell you, do you take the whole half or do you take a little bit of the half, right? So because the limit goes from 0 to 3, you don't even take the whole. So this will be a quarter of the area, will be pi r squared, right? Because it only takes from 0 to 3. And the same thing if it went from -3 to 0. Then out of the top half, because that's the top half, you only take the part where the x goes from -3 to 0. So again, you take a quarter of a circle. Okay. So you could get a problem like that, but unfortunately, you're not going to be told use geometry to do that. But if if it's something weird like that, you can't use substitution. Not the substitution that you know, that won't work. With what again? Yeah, but there's also another one, Brian. There's another one in the, isn't there? Hold on before I talk. Just a minute. I thought I put some other one there as well. Plus there is one, there is one in our notes, Brian. You can go to in our notes, and I have one just like, okay, so I don't have one in the extra. I don't think so. Do I? Okay, I can look through it. Okay. So if you can look at our notes, we have a problem that looks just like that in the notes. And I've done it two ways, method 1, method 2. So the problem that I have there is pretty good. It's slightly harder than if it was, let's say, a nice straightforward parabola. That's straightforward. So the vertex here will be opposite of what shows up there. So that's 0. Exactly what shows up there. And the parabola goes up. So that's a little easier parabola to play with, because it goes through -3, right? And then you have a line that goes, but it's similar to the one they gave you. The one they gave you has a little harder, it's a harder picture slightly, right? So But there is one in the notes that's similar to it. Now, I can come with one, but it won't have nice intersection points because I need to think about it backwards, and I can't right now. So regardless of what it is, right? So you have something like that. So this is a problem that goes like this, right? Vertex is at 4. So let's say you have a line y equal to x plus 1. The intersection points are going to be horrific now. Whatever. You asked for it. So it goes like that, right? Similar idea. First you draw it, you really need those intersection points, you hope for the best. If that was a problem where I had to think about it a little bit more carefully, I will give you nicer numbers here so things work out. I didn't, so too bad. So this y is equal to that y, so x plus 1 is equal to 4 minus x squared. That is pretty unfortunate because you have now x squared plus x minus 3 is equal to 0. Oh dear. So there's no, doesn't factor, and you use the quadratic formula. So those intersection points are horrific because they have roots. That's not going to be the case on an exam. So now you're asked to, so let's say you have the intersection points. They're not nasty like that. There's something nice. So I don't know. So let's say that was a 2 magically, because I forgot. It's supposed to be 2 there. So let's make that a 2. So then it factors, right? So you have, what is it? X plus 3, x minus 1 equal to 0. You say, awesome, fantastic. So I have 1, negative 3 and 1 again. So again, you're going to be asked to find the area. If you were to evaluate with vertical line segments, that is line segments whose length goes up and down, right? So that is the width of the line segments, the fatness of it goes left and right. That's the dx. You integrate with respect to x. So if you put a vertical line segment inside here, no matter where you put it, the bottom stays on the line, the top stays on parabola. So that tells you one integral. The width of the line segment goes left and right. The line segment can go left and can go right. That means you're integrating with respect to x. And what are you integrating? You're always integrating the length of that segment. The length is a y coordinate minus a y coordinate. So the y of the parabola minus the y of the line. So I'm not saying put y minus y. I'm not saying that. I'm saying put what y is equal to minus what y is equal to, right? So I'm going to take the large y on the parabola. That's what y is equal to on the parabola, minus the y on the line, minus the y on the line. And that line segment goes all the way from the left, and it can go all the way to the right, from this x to that x. So from negative 3 to 1. So that's the easy one. The hard one is if you try to integrate with respect to y. That means you put the line segment lying down, and the width of it goes up and down. That is, your line segment can go anywhere high and anywhere low. That means you're integrating with respect to y. So if you integrate with respect to y, here again should be the length of the line segment. If this is with respect to y, the length is in terms of x's. That is, you say what x is equal to and what x is equal to. The length is going to be a horizontal length where you have to subtract x's, right? So that means your line segment goes this way. And as you're putting this line segment, you notice that after this point, the right end point of the line segment jumps from the parabola to the line. So the moment it jumps one end of the line segment, you need to use a different integral. So you need two integrals with respect to y. Oops, what happens? So one integral for the top part. And the top part goes from the very big y here to the small y there. And that comes from the vertex and from whatever the intersection point here was, right? So that's the very large y, whatever the small y was in the intersection point. And what are you subtracting? The x you find in the length. You're subtracting the x's. The large x, subtract the small x. Like the large x is the one on the right, the small x is the one on the left. So you subtract from the large x, the small x. Both of those x's are on the parabola. So you need to take the equation of this parabola and solve for x. It's clear which one's the large x, the plus, which one's the small x, the minus. So you're supposed to take the large x, the one over here, that's the one with the plus. What was on the other side? 4 minus y. And subtract the small x, this guy, which is minus root. Take the large, subtract the small. So that's going to be large x square root minus a minus square root. So it's two square roots. Square root minus a minus square root, right? So that's one. So the other one is going to be this. So that y goes from the y down here to the y up here. I don't know what these things are, but those should match. And you're subtracting again 2x coordinates. The large x, subtract the small x. The large x is the one on the line. So you go to the line and solve for x, right? So x is equal to 1/2 y minus 1. That's the large x, the one on the right. So you take the large x, which is 1/2. What was it? Y plus 1 minus 1 minus 1. And subtract the small x. Small x is on the parabola, and that was the negative one. Dy. You're not going to be asked to evaluate. You're going to be asked to set it up. So number one, you find points of intersection. You need to know how to draw a parabola. And once you find the points of intersection, you should be able to draw this thing, right? You don't need to draw the axis. If you worry about where the axes land, okay, leave them aside. And just put the parabola and put the line and put the intersection points you found. You should be okay, because that's enough to set up the integrals that you're going to be asked to set up. So right, because in order, if you integrate with respect to y, inside the integral you should have y's. So you should not tell me what y is equal to, because y is equal to x's. You're not allowed to write x's. You need to tell me what x is equal to. X is equal to y stuff. So inside the integral, if you integrate with respect to y, you should have y's. Yes, handwritten points. Okay, so number 14. There are 14 problems. Okay. You serious? Isn't that in the notes with solution? Okay, I'm pretty sure that has a solution in the notes. So Fourier optimization. Oh, okay, fine. I'll find it. Nope. Oh, there it is. Hold on. What did I say? 4E? Oh, it's there. 4E is there. Which problem I said? Example 2. does that mean example 2? Example 1. Oh, example 2. Yes, example 2. Okay. So you have a fence, rectangle. So the rectangle must have a fixed area. The area is equal to 1600 square feet. Again, units don't matter until the end. When you ask the question, you have, well, you did all the math and stuff and found the answer, go back, find the units, make sure you have the correct units. Okay. So if somebody says dimensions cannot be feet squared, it will be feet by feet by feet. There's another fourth dimension by feet. Okay, so they're feet. All right, and dollars. So you're gonna put fence. You're gonna put a cheap fence where people don't look at it, and a fancy fence where people look at it. Look at it. So 3 sides have the cheap one. You have no neighbors there. So this is $40. Oh, it's not cheap per foot. $40 per foot. That's ridiculous. Okay. So $40, you'll say, how do you know which one is the 40? I don't. No clue. Maybe 40 is here and here and here. But I also did not tell you what the size are. Maybe the side that looks small, maybe that's the big size. I don't know. Maybe that's the big, side. We have no idea yet. So 3 sides are cost $40 per foot. So if one side is 10 feet, that will cost you 40 times 10. If it's 2 feet, it will cost you 40 times 2, so on. Okay, so per foot, right? The other side's the expensive one. So one of them is expensive. So that's 120. That's crazy. It's made out of gold. So per foot. So find the dimensions of the least expensive rectangle. So you want minimum cost. So the first thing you need to do is write the cost function. Second thing you need to make sure the cost function has one variable. Third thing you need to do, find the minimum for that function. So that means you have to take a derivative. And then when you answer the question, you have to put units. Okay. Now, to make life easier, if that was a problem, let's say in the exam, somebody who would need to grade this will probably not give you an option on the name of the variable. So let's say this is X and this is Y. It's a rectangle. So you have 2 X's and then you have 2 Y's. So if this side costs $40 per foot, us does this. Us does this. But this cost an arm and a leg to put the fence. What's the cost of the bottom side only? Yes, 40x. How about the cost of the left side? This side. What's the cost of that side? Well, the left side is 40y. The right side is another 40y. And the top is 120x. Okay, so that's a problem. It's like a salad. You have x's, you have y's. You can't have a function of 2 variables in this class, right? So you have the cost. It looks like it's a bunch of x's, 160, wait a minute. Yeah, that's x. 160 x's plus 80 y's. Okay, so you want to get rid of one of the variables. So there must be something else in the problem that relates the x and the y that allows you to replace one of them and write it in terms of the other. So what was given in the problem that allows me to relate the 2 variables? This area. Area is x times y, and that's 1600. That allows you to get rid of one of the variables. That's right. So since x times y is 1600, it doesn't matter which one you get rid of. Which one do you want to get rid of? It really doesn't matter. Or which one do you want to get rid of? Pick one. Which one? You can get rid of x or you can get rid of x. Awesome. Let's get rid of x. That means we need to solve for x so we can get rid of it. So solve for x. So we have 1600 over y. So I'm going to plug in. So this is a function of y. It's going to only have y's. 160. I replace the x. You can simplify. Not planning to do such a thing. And I'm going to take a derivative because I want to find the minimum of this function. Clearly, the y measures this width. It can't be negative. Okay, it clearly cannot be 0. I can't have like a rectangle that has 0 width. So it's really starting at non-zero. But you could, if you want to, say pretend start at 0 and goes, it can be as big as whatever, right? So the domain for y can be, okay, not really 0, but if you want, you can include it and any positive number. All right, so I'm going to take the derivative to find a minimum. So I need the critical point. So the constant state, don't care what this is. The derivative of 1 over y is negative 1 over y squared. That's the derivative, right? Because 1 over y is y to the negative 1. So you take the derivative, you bring the negative 1 down and make the power 1 less. So now I'm going to take the derivative of this. So you have a critical point where the derivative is equal to 0 or undefined. Yes, the derivative is undefined if y is equal to 0, but we're not looking for a rectangle with no width. So that's silly. So I'm going to set this equal to 0. So I'm going to solve for y. So I'm going to separate the non-y stuff from the y. So I'm going to move this guy on the other side. Again, I don't care to simplify. I do not multiply this because at some point you'll be able to simplify stuff before you're forced to multiply anything. So negative 1 over y squared, that's this negative, is equal to negative 80. So the negatives go away. Good news. Okay, because y squared cannot be negative. So I'm solving for y squared. So 80 over, again, leave those things as they are. Solving for y squared. If 1 over y squared is that, y squared is the reciprocal. Now, can you simplify? Yeah. Yes, you can. Okay, we can get rid of a 0. We can get rid of that. Okay, so I have 2 of these. Do I need to simplify further? Absolutely not. Okay, but you could, if you want to, realize this is 16 times 100, both of which are perfect squares. What do you mean, can I cancel the x? Where do I cancel the x? Oh, yeah, okay, don't cancel them. All right, so that's what y squared is equal to. Remember, this is not the place where we're going to write y is equal to plus or minus. There's no minus width. It's plus. So y is square root of this. Now, if you're not 1,000%, there's no such thing. If you're not 100% that your calculations are correct, I wouldn't bother doing what I just did. I would just write this thing, flip it, and put a root over it. It's the correct answer, right? Nobody will penalize you for not simplifying, but they will penalize you if you simplify incorrectly. So can this simplify further? Yeah. Do I care to? No, but I will here, but don't in the exam. So that's what y is equal to. That doesn't mean this is where you have a minimum cost. So now you need to show that, yeah, this is where I have a minimum cost. The only thing you need to do, this is your 0, y. This is your infinity, y. And here's the only other number that you found, whatever that root is. What are you looking for? The cost function. What do you want to have? A minimum cost. So the function, this is the derivative. The function must be going down and then up to have a minimum. So you can really fake it. The derivative must be negative here and positive there. When I say fake it, I don't mean do this. Don't know what that is, other than there are a bunch of lines and some signs. You need to say what this is. You need to say what the function is. You need to put something here, something there, and you need to put something about the function here, right? So something has to show up here. Those cannot be not there, right? So this is important. Once you have that, then you know minimum happens when one of the dimensions is this number. And the question would be, what are the dimensions? Since one of them is 40 root 2, the other one was, what was the other one? 1600 over whatever that number is. So the dimensions are 40 root 2 feet by 1600 over 40 root 2 feet. Again, don't have to simplify this, but you do need to put the units next to it. You'll get the same answer regardless. Regardless of what's what, the dimensions are going to be identical, right? So what was the question? When did you take? What does that mean? What do you mean be here? I don't understand. Yes, absolutely. You should write everything with unsimplified results, stick units there. So I wouldn't simplify anything. You know, you saw me, I wrote, instead of, what was it? Horrific. Instead of writing this, what did I write? I'm not even taking an exam, right? Don't simplify anything, nothing, but write it neatly, because here's a grader who's going to be grading, let's say, that problem, and he has to grade thousands of that one problem. So those of you who have a handwriting that's like this, nobody sees except you, don't do that, especially if you're not going to simplify. Everything has to be clear, right? I'll go check as much as I can. Really, I'm not going to check all the papers, but I'll check some stuff to make sure there are no mistakes in the grading that's done. So everything you write has to be clear. If what you write is clear, even if it's not simplified, as long as it's clear, right, you should get the full credit. I will check that this did happen. Okay. All right. What did you ask me here? I don't understand what your question is. So if you're talking about the again 160 x plus a bunch of y's, and we had to get rid of one of them, right? And we have x, y is equal to 1600, right? And you can get rid of whichever, doesn't matter which one you want to get rid of. We got rid of the x's, and we have all y's, and we took the derivative with respect to y. These are independent variables. Or you can get rid of the y, right? So this is going to become c is equal to 160x plus 1600, that's the y, times 80. You can do that. Here's the y. And then take that derivative. And now you're going to x first, before we found y first, right? And you're still going to do the same thing. You find that it goes from 0 to infinity. You're still going to say the derivative must be negative and then positive, because I'm really pretty sure I found a minimum. You're not going to say I'm pretty sure. You are sure? Units. Only you're giving the x units first. The x value first. It's fine. It's the same thing. Okay. Any other questions? Um, yes, so give me a second. 15. So instead of 15, oh, that's a different one. Let's do 15. That's fine. We can do 15. So 15 is absolute extrema. I have something similar here. Hold on. Yeah. So also do number 10 in the review, in the handwritten review. Do number 10. So 15 says find critical points. So you have a function that has one piece, let's call it f1, another piece, and another piece, 3 pieces. And this piece is defined from 0 to 1, excluding 1. This piece is defined from 1 to 2, and this piece is defined from 2, including 2, all the way to 4. So in order to find critical points, what do? We take the function, take the derivative, set it equal to 0, or say where it's undefined. It's not going to be undefined here. And the x's that make the derivative 0 are possibly critical points as long as they're in the domain. You need to do this 3 times now. You need to take the derivative of this, set it equal to 0, find the x's that are in here that make that derivative equal to 0. Do the same thing for f2, do the same thing for f3, for all 3 pieces. So then you're going to take those critical points as long as the first ones are here, the second ones are here, and the third ones are here. If they're not, don't ignore them, right? Don't use them. Take those critical points, and you're going to take the endpoints. For absolute extrema, you take not only the critical points, you take the endpoints. But now you have many endpoints. You have this one, that one, that one, and that one. You take all those x's, the critical points x's, and all those x's at the endpoints, and you evaluate the function at all those points, right? So you're going to take the first piece. So the function was, the function was so this is the last interval. This is the interval from 1 to 2, and this is the interval from 0 to 1. So I'm going to take the derivative of the first piece, right? So the derivative of sine is cosine, and the chain rule says the derivative of pi x, which is another pi, so the pi's disappear. So the answer is cosine of pi over x. And the question is, when is cosine is equal to 0? Cosine is equal to 0 here and here. That's when cosine is equal to 0. So cosine is equal to 0 at pi over 2 at 90 degrees and at negative 90 degrees. Pi over 2 and negative pi over 2. And 3 pi over 2. It can go down, right? Counterclockwise. So the cosine is equal to 0 if this angle is pi over 2, 3 pi over 2, a lot more pi over 2, which is you don't have enough of here, or negative pi over 2, and so on. So if the angle is pi over 2, that means the x is a half. You look and you ask, is that x inside that domain of the function I used? Yes. So a half is a critical point. This is a little harder problem that you should expect because of the fact that there's a sign there and the sign becomes 0. The cosine becomes 0 again, 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 again. In this case, only this is a critical point. Every other x that makes the cosine 0 is not going to be in this domain. Now you take the second derivative. Second derivative is equal to 2. Well, that's never 0, so there's no critical point to worry about. Then you take the third function, take the derivative of the third piece. That derivative is equal to negative 2x plus 6. You need to see, is that 0 for any of those x's? These x's, not any other x's, right? So you set it equal to 0, and you say, yep, this is equal to 0 when x is equal to 3, and that x is in that domain. So I found two critical points. I'm going to take those critical points, and I'm going to take all the endpoints, which are all of them, 0, 1, 2, and 4. And evaluate the function at all those points. But when you, so where do I plug in, for example, this? I plug that x equals 0 to the correct piece of the function that allows me to plug in x equal to 0. So if I want to know what f of 0 is, I need to go here, because that's when x is equal to 0. If I want to know what f of 4 is, I need to go here. If I want to know what f of 2 is, I can't go there, because x is not equal to 2. I still have to go here. If I want to know what f of 3 is, again, I have to go here. So for 2 and 3 and 4, I have to go to the last piece. For 0, I have to go here, and for 1, I have to go here. And for the half, I have to also go here, right? So you have to go to the correct piece to plug in. You can't just pick whichever one you want to plug in, right? So once you plug in the largest, then compare those y coordinates, these things here. The largest is the absolute maximum. That number, not the point, the number, the largest y is the absolute maximum. The smallest of the y values is the absolute minimum. So again, there's a, I thought there was a similar problem, maybe not. I don't remember. Yes, there is a similar problem on the number 10, the handwritten notes. You should do slightly friendlier, and it's more like an, not as confusing with the sine and cosine there. Anyway, more appropriate, let's say, for an exam. You mean on the previous problem, Brian, with the word problem? Absolutely. That part, if you need to show, you did something to show that you know that's a minimum. Otherwise, just because you find a critical point, it could be that we wrote the wrong problem, and that function only has a maximum. It doesn't have a minimum. So you absolutely have to do the little table there. X equal 2. For which one? Handwritten notes, number 10. Which one you said x equal 2? Number 10. Well, I don't know. So let's see. Did I take the derivative? So the derivative is, so in that case, you have two pieces. And the other piece, 16/5 minus 2/5 x. And this goes from 2 to 10, and this goes from 0 to 2. Does not include 2, right? So x is not 2 here. X is 2 here. Okay, so you take the first piece, take the derivative. So that would be 3x squared minus 30x plus 27. You see a factor, a common factor, 3, so you factor it correctly. If you have something like that, it will be factorable. So this hopefully is factorable, don't know. So I want two numbers whose product is 9. Really? And whose sum is, oh, that's better. That didn't work otherwise. 10, don't do that in the exam. I mean, you can tell. If I noticed it wasn't factorable, so there was a mistake. So I had to go fix it. Anyway, so, okay, so if it's positive 9, then they're both positive or both negative. Clearly, they're both negative, so negative 9, negative 1. So x equal 9 and x equal 1. So I look, where did that function come from? It came from here. That has this domain. So I only need to include those x's that I found that they're in that domain. So I cannot include that. But I can include this because it belongs in that domain, right? So this is, in fact, a critical point. The endpoints are not critical points unless you specifically saw that the derivative becomes 0 there. It doesn't. Plus, x equals 2 is not in the domain there anyway. So now I'm going to look at the other piece. And I'm going to take the other piece and take the derivative. Well, that's going to become 0. Is that what I have there? Yeah. And that becomes something else. Clearly, that's never 0, so no critical points there. So I only have one critical point. 1. Right? The one critical point is x equal 1. And now I have to create a table with a critical point and all the endpoints, all of them. And the endpoints are 0, 2, and 10. So those have to be included. So I'm going to have the critical point I found, 1, and the endpoint 0, 2, and 10. And I'm going to evaluate the function at each one of those. So if I want to plug in x equal 1 into the function, I'm going to go to the part that allows x equal 1. So I'm going to go here, plug in x equal 1, and I get something. Right here, you actually have to add. I don't feel like doing that. So I'm going to go to the top part and plug in 1. Then if I want to plug in 0, I'm going to go to the part that allows 0. So which one allows 0? This one allows 0. So I'm going to plug in, okay, that's easy. So that gives me 6. If I'm going to plug in 2, I need to go to the part that allows x equal 2. So I'm going to go check. This is the part that allows x equal 2. So I need to plug in x equal 2 here. Okay? So that gives me whatever minus 4/5, or whatever that is, 12/5, which is 2 point something, 2.4 or something. Okay, so I mean, I have to compare these. I have to get an idea. I don't need to know exactly what they're equal to, but I have to have I don't have to simplify it, but at least I have to have an idea which is larger, which is smaller, right? That's all that's important. And then I have to plug in 10. Where do I go and plug in 10? Clearly here, because 10 is allowed on this piece only. So I plug in 10, right? So plug in 10, so you have 16/5 minus 20/5. So that's clearly a negative number. That looks like a minimum. I don't know. I didn't do this one, so I don't know which one's a minimum. But anyway, if all of them are positive except the last one, clearly that's the absolute minimum. So I would say absolute minimum is this number, and occurs, this minimum happens at x equal 10, right? If you have a question like that for absolute maximum minimum, you'll be asked both for the absolute maximum, absolute minimum, and where they occur. So you need to answer absolute maximum, absolute minimum is which y coordinate, and at what x this thing happens, right? Don't give them as a point because you will get no points back. You can't give a point. You have to give them separately. This is the absolute maximum. That's the y coordinate. And it happens at this x. Okay. Yeah, so this one's more exam appropriate because it doesn't have the sine and cosine stuff because they repeat again and again. They become 0. It's a lot more work for a final anyway. So what time is it? Okay, any last couple of questions? So, okay, I would strongly advise you to do what I've said before. Start with the handwritten notes with those type of problems. Those also say do those problems in the other review, not handwritten notes, handwritten review. Those also say go to the other review and do those problems first. Also do those that I mentioned in the other review, but do the ones in the handwritten review. Any other questions? Okay, you guys should be okay. You know, just control your urge to simplify. Just kill it. The urge to simplify in an exam. It shouldn't be happening. Just don't do it. And definitely don't leave anything blank. Absolutely. Thank you. The answer is most definitely. Yeah. So look at those and look at the problems I said in the review. The handwritten says in the final review that's posted in the all section site and also on our site or whatever I said there, do problems number 1, A, B, C, whatever, number 3, those two, and then do the handwritten ones on the review. Which review? The review 9C. I assume that's the one. 9C. 9C. No. Hold on. Is that the one with the tangent line of the inverse? Okay. So if you found the tangent line to, that's line, to y equal f of x at 3 comma 5 is y minus 5 is equal to, let's say, I don't know, 2/7, x minus 3. Then if you know the equation of the tangent line to the graph of f, then the equation of tangent to f inverse at the reverse point, so not 3, 5, 5, 3, and they won't tell you that because, you know, they want to be cute. They won't say 5, 3, but that's what they will mean. So, I mean, they can't ask you anything else, frankly, because unless they give you the function, they're not going to give you the function. So the only point they can give you on the inverse is the reverse one. So, but instead of saying 5, 3, they want to be super cute, can't help themselves. So they'll say at x equal f of 3. And you're like, no problem, let me see. F of 3 was 5. So you mean at x equal 5. See, they're being silly. So that means at x equal f of 3, which is 5. So they're really giving you the reverse point. So at the reverse point, the equation of this tangent line to the inverse, the 5 and the 3 flip, and this also flips that way. So it's going to be y, not minus 5, minus 3 that way, but minus 3, minus 5. And that number flips. It doesn't change sign. It stays the same sign. So if you know the equation of a tangent, and there is an inverse, you can write the equation of the inverse at the flip point. Okay. Yeah, I'm going back and forth. One coffee and the other coffee. So was it number 5? Number 5. So let's see, what's number 5? Anything good? Yeah, that's good. You should do number 5. Okay. Why am my handwriting so tiny? Okay, so we have so if you have an integral from a to b, the definition is this is the limit of a Riemann sum. And this is correct only if the intervals, if you took the graph and you took the region and cut it into intervals of equal width. Otherwise, this is not correct. Anyway, that's what we're assuming there, that they're equal width, whatever. So then what you're going to have there, you're going to have f of xk times delta x, where the xk is going to be, well, it depends. If you use the left endpoint, then the first xk is a, the second one is a plus delta x, the next one is a plus 2 delta x, and so on. If you use the right endpoints, the first xk is going to be a plus delta x, the second one is a plus 2 delta x, third one is so on. So whatever the function is that nobody's going to give you can tell what it is, because instead of x's, you're going to have this number plus a bunch of delta x's, and you won't say delta x. You will see in the formula what delta x is equal to. Delta x is always equal to b minus a over n. Your delta x will have a capital N in the denominator. So whatever you see, if you see here something that looks like that, if you see inside here something that looks like sine of 2 plus k 3 over n plus 1 over 2 plus k 3 over n plus 5, and that's multiplied by 3 over n. That tells me this is my delta x. And I see it again. Here's my delta x, and I see it here, and I see k of them, like I'm supposed to. See, I'm supposed to, 1 of them, 2 of them, 3 of them, k of them, and I see it here. So the quantity that has k delta x is plus a constant, that quantity is your x, right? So this is your x, this is your x. So your function is sine of x plus 1 over x plus 5. That's your function. So in this problem, you have some limit. Okay, it's getting late, so my handwriting is getting atrocious. That's not 23. This number is not 23. It's 2. Don't know where I wrote 3. Oh, yeah, no, I do know. But anyway, never mind. It's not 23. So you have this thing to whatever power times 9 over n. This will have the form f of xk. You'll see some k's inside it, times delta x. Delta x is going to be some number over n. Here it is. That's your delta x. And whatever you see it again, here it is. Oops, sorry. Here it is. You have k of them. There it is. So the k delta x is plus the constant. That constant will be the a. Notice the integral went from 2, there's the a. So that constant will always be the a. So this a plus a bunch of delta x's, this is your x. So that means you need to take this and realize this is your x in the function. This is your delta x. So your function is x to the 3/2. That's the function. K squared, K to the third. No. Did I mention that? What do you mean K squared and K to the third? Oh, you mean those things? No. No. Yeah, no. But you will in calculus too, not here. What do you mean K equal to? K is not equal to that. I see what you mean. Do you mean this 1 plus 2 plus 3 plus all the way to n? Yeah, okay. That is equal to that. Okay, any last question? Yeah, you're not gonna really need it. I don't think so. No. Okay. Just do the handwritten notes. I mean, there was a mistake, as I said. This, I don't know why I can't write sigma. This was 2. It's not 23. Doesn't make sense. This number will be the same thing as whatever A is. You'll see it there. 12. Yeah, that's good too. So this is when x is less than 3. F is x squared plus 2x plus a. When x is between 3 and 4, and if x is greater than 4, then this is 2bx plus 4. So we know that the function is continuous. Continuous means at any x, let's say x equal 3, the limit of f as x goes to at any x from the left is equal to the limit of f as x equals 3 from the right is equal to f of 3. That's continuity. At every point, the two sides arrive at the same point, and that point is there. Okay, so we want to find a and b. So this is a continuous function. The only place where it has a problem is, oops, what's happening? What did I do? Is at 3, but 3 is not part of the domain, so it doesn't work. This has no problem whatsoever, and neither does this. So all these are continuous. So in order for this function to be continuous, what? Hold on. Did I say that? Yeah, because I went from to 1, I was trying to write the solutions, and I'm like, where's 4? 4 is missing. That's why it's mysterious. Don't you think it's mysterious? I went 1, 2, 3, 5. That's a mystery, right? There's no, I mean, I don't see, I don't think I included the 4. What was I thinking? Clearly I wasn't. Okay, that's why. Things happen a lot lately. Okay, let's go on. Okay, so if a function is continuous, I really have to check it where the definition of the function changes, or the place where you have breaks. I have to check that it's continuous. So I have to check at 3 and I have to check at 4, right? At 3, the definition changes. So whatever this piece, the graph of this piece is, let's say like that, it better touch the graph of this piece. It better touch, because otherwise not continuous. It says it's continuous. So I'm going to look the limit of the function at 3 from left and right should be equal to the limit of the function at 4 from left and right. Those should also be equal to each other. And hopefully I'll have enough equations to solve for a and b. Frankly, I only need 2 equations because I have 2 unknowns. So I'll create one equation by taking limits left and right of 3, and take another equation by setting the limits from the right and left of 4 equal to each other, right? So at x equal 3, there it is at x equal 3. So at x equal 3, from the left, the function is this, right? So the limit as x goes to 3 from the left, the function is that. So I'm going to write, and I'm going to factor it. Must be equal to the limit as x it goes to 3 from the right, and that function is this because that's when it's coming from the right. Okay, so I'm going to do the easy limit first, this one, just plug in. So I have 9 plus 6 plus a must be equal to. So if you find a limit on the other side, then you can find a, right? You have a already. So, so if x goes to 3 from the left, that means x is not 3, right? It's going to 3. It's not 3, and it's also less than 3. If x is less than 3, this quantity inside is definitely negative, the quantity inside. So if I want to get rid of the absolute value, what do I have to do in the denominator? The negative, right? So I have to write this. Again, I'm not evaluating the limit yet. I'm simplifying it. I already have the other limit. And now I can simplify the fraction. So I have negative 2. So negative 2 is equal to 15 plus a. Please don't add, unless you're sure. 9 plus 6, 15. Otherwise, I wouldn't add. I just move everything on the other side and say a is this. Leave it for somebody else to add. I wouldn't do it. So that's negative 17. So you have a. That's good. We'll do the same thing for the other place where the definition of the function changes. So the definition of the function also changes at 4. Before 4 is this, after 4 is this. So I already know the a, so I'm going to plug it in, right? So the limit of f as x goes to 4 from the left is equal to the limit of f as x goes to 4 from the right. From the left, the function was that polynomial, so it's x squared plus 2x plus a, which I already know the a is 17, is equal to the limit as x goes to 4 from the right of f, and from the right f is 2bx plus 4. So I plug in here the 4 and I plug in here the 4. Clearly I can find b, right? So all I have to do is plug in. So I plug in, I get 16 plus 8 minus 17 is equal to, again, if I was an exam, I would write 4 squared plus 2 times not a chance, not multiplying anything. I mean, somebody coughs next to you, or I talk and then you're like, oh yeah, 16. Number changes. It's very easy. So 2 times b times 4 plus 4, you can clearly solve for b. Even if it looks horrific, doesn't matter. If it's correct, it's correct. Okay? So now you have both a and b. That's a standard problem on an exam. Use continuity to find two unknowns. So anything else? Okay, so look at the handwritten notes. And then look at the problems I'm suggesting there in the non-handwritten review. Okay. And you should be okay. All right. I'll be up probably forever. So if you have any questions, you can send it to me. 13F, sure, fine. I'll do that one. Oh, that's a good one too. Yes. So this is similar to the one we did before. It's so small, 2/3. Okay, 2/3. So if the power was decent, like 23, and you can do this, it will take you a while, but you can expand, right? And multiply by x and undo it. But the power is not nice. It's a fraction. You can expand something that has a fraction as a power. You can expand it. So what you need to do, and it's not the problem that, again, as I said in the previous example, in the other example we did earlier, that's similar to that. The problem is not really the power only. It's the fact that inside the power you have two terms. If you only had one term, that's not an issue, right? It's the fact that you have two terms there. So you need to get rid of that. You really want that stuff under the non-integer power to be one term. So you want this to be one thing, this whole thing. That gives it away what you should do. You should make a substitution and call this thing that has two terms, one, call it u. Okay, so let u be equal to x minus 4. So this way you just have a simple u in here. Then du is equal to dx. It's the derivative, which is 1 times dx. So you know this is going to be replaced, this thing is going to be replaced by u to the 2/3. But you also have to replace the x. Well, let's see. The x needs to be replaced by u plus 4. And you also need to replace the dx. So let's see, dx is du. So now you know the substitution. This is going to be u plus 4 in a parenthesis. This is u to the 2/3, that's a 3 here. And this is du. Now I can distribute, right? Distribute and distribute. So you have u times u to the 2/3 plus 4 u to the 2/3 du integral. So you add the powers, right? 1 plus 2/3 is 3/3 plus 2/3 is 5/3. I haven't integrated anything yet. And now you use the power rule that says if n is not -1, then the integral is x to one higher power, the higher power plus c. Okay, so this is u to the 5/3 plus 1. Don't add, please don't add. And you get, I don't know, 2 or something. 5/3 plus 1. U to the 2/3 plus 1 over 2/3 plus 1 plus c. Even if you write the c here, if you forget it here, you lost points. Don't want to do that. When the integral disappears, a plus c should show up, unless it's a definite integral. And of course, you're not done. The last thing you need to do is go ahead and take all the u's and replace them by whatever they're equal to. Replace them by x minus 4. Right? So I would just go ahead and rewrite everything. X minus 4 to the 8/3 over 8/3. Again, don't have to write that. Don't simplify it. Plus 4 over whatever 5/3. And then x minus 4 to 5/3 plus c. Okay. Okay. So again, you keep on working on it. You do need to take a break though and sleep and eat or whatever, so you're relaxed in the exam. It should be okay for the exam. Just do those problems. All right. So unless there's a last minute question, I think we're probably done for today. No, you gotta sleep for the final. 13A. What's 13A? Okay, so let me show you 13A, and you should do 13B also while you're at it. Frankly, 13C and 13E. Also 13D. You should do 13. The whole 13 is good. All of the 13 should be done. So 13A, I'll do this. Okay, so I see log x. The derivative of log x is 1 over x. It's there. So I know the substitution. U is log x. It happens to be in the denominator. I don't care. U can be anywhere, right? The du has to be exactly the way I'm going to write it. The du is 1 over x dx. That's exactly what it's supposed to be. That is 1 over x dx. That's going to go away, and in place of it, I'm going to put a du. So this integral is 4 over u du. And of course, it needs limits. The x limits went from e squared to e to the 4th. U is log of whatever x is. So u goes log of whatever x is to log of whatever x is. That cancels, that cancels. So u goes from 2 to 4. Since I changed the limits, I never have to go back to x's now. I can just finish this, just the way it is. So this, the 4 can come out. The integral of 1 over u is just log. It's really absolute value, but I don't really need it here from 2 to 4. So you plug in 4 and then you plug in 2. So the other 4 stays outside. Natural log of 4 minus natural log of 2. Okay. Okay, so Ariane, if you have a question, you can stay behind. Yes. Was that it? Okay, so anyway, you can take some time to work more of these problems. Just work everything that's handwritten. You should do all of these. All of those problems you should do. What do you mean X? You mean in here? Okay, so this integral can be written as 4 over natural log of x times 1 over x dx. Yes, I can do that. And I can also take the 4 out while I'm at it, since really, if there's a constant, just get it out of the way. So now when I make the substitution, I want to make u this thing whose derivative is kind of there, waiting for me. So I know the derivative of log is this. So I want to make u log, not 1 over log, log. The derivative of 1 over log is not 1 over x, right? So du is 1 over x dx. Sure enough, this whole thing is here. So this is my du. There it is. And since this guy is u, I have this guy's u, this guy only. The integral becomes 4, 1 over u du. Okay? In the other case, you had that with a 4 again. Take the 4 out. So again, your u is your log, only in this case in the numerator, and du is again where it's supposed to be. The x is in the denominator, the dx is in the numerator. So this whole thing now is exactly that. That's your du. So this integral will become 4 u du with the same limits, 2 and 4. That's slightly easier, right? Anyway, okay. All right, so I think those problems should more than prepare you for the exam. You should do okay on the exam, more than okay. All right, so I'll see you guys tomorrow. If you have any questions, you can email me. If you have any private questions or whatever, you can stay behind. Can you scroll up? How far up? This up? Let me go to my email. It's have you been in class? Have you seen our site? It's on the site. Okay, go to the homepage at DDA. Go to the homepage, and you see there's some people flying there, whatever, in the salt water thingy. There's my name, and then isn't that my email there? In any case, if you go to your Rutgers account and you write Ioana Mavrea, I'm pretty much the only one. I'm the only one. So they'll find you, or they'll find me. Or you can put Ioana.Mavrea@Rutgers. Yeah, okay, good. All right, have a good night, everyone. Get some sleep. Some people beg to differ. Okay, get some sleep. See you guys tomorrow. Get some rest. I don't want anybody coming not having slept. I'll send you back. Okay, so stay behind if you have a question. I know